Imagine you have an infrastructure team of one, and they own infrastructure responsible for streaming 2 trillion events a day for customers like OpenAI and Figma. How do you get past this, where you have like one person holding it all together? That's what we're going to find out. Joining me is Tyrone Wong, infrastructure engineer who helped Statsig turn that chaos into self-service. So yeah, welcome Tyrone. Is that true? Is it 2 trillion events a day? That's insane.
Yeah, and that's actually like based on a recent milestone. We actually might be processing more, to be honest. As we onboard more customers, this number is just continuing to skyrocket. And so this was a milestone we hit maybe like 2 months ago. So I actually haven't checked it recently, so it actually might be even higher.
So yeah, how did you overcome this issue of just having a single person as the key to this whole infrastructure?
Yeah, for sure. So the title of this is Says to Self-Serve and how we used GitOps to Pulumify our infrastructure and supercharge 2 trillion events a day. So essentially, like before I give this context, I'll explain like who we are at Statsig. We're the one-stop shop for experimentation and observability here. And so we do feature file experience, product analytics, and a whole lot more. And as you mentioned, we process 2 trillion events a day. And all these trillion events come from like a lot of like key customers. And so as Andrew mentioned, we had one infrastructure engineer to sort of like tackle this entire thing here. And so eventually as we grew as a company, there were definitely some issues we need to tackle. And so I'm going to talk about the challenge, what we built, and then essentially the vision we had ahead now that we have this infrastructure built for us. So the singular engineer at the time was Jason Wang. And I remember when I first joined Statsig, we were around 20 engineers, and he was the primary contact point for anything related to cloud infrastructure. And he was the go-to person whenever you needed like a new service, anything specific Kubernetes wise. And so everything funneled through him. And essentially, there's the joke that, if he got hit by a bus, what would we do without Jason? And so that was definitely a pressing concern because he was the one master key to unlock everything here. And we eventually did run into this challenge, not through a bus, but through something called parental leave. Jason became a father and sort of went to take care of his baby. And we were now wondering, what would we do now? And essentially, how could we scale out this problem here? So to talk about the problems we were facing and why we sort of built this whole Pulumi framework using Argo CD and all, we were running into things like manual labor and disjoint setup in the sense that an engineer could have this one idea, build a service, and want to deploy it, and it would be like, okay, I've written out my code, I just want this up and running. Who do I have to go talk to? What kind of procedures do I need to jump into? And so there's a lot of manual process as well. And so finding the manual process and then getting the correct context from different people was definitely slowing us down, especially as we grew and we needed to ship more services. And then, like I mentioned earlier, like if that one person is just not present in the office that day, sick or anything, that just means that you have to wait for that hyper-specific context, and that sort of kills momentum, especially when you're trying to ship things fast here at Statsig. And lastly, right, as an experimentation platform, the things that help people move fast is actually comfort and safety. You can ship things fast when you know that there are the appropriate guardrails there to let you know that if you can fail safely, and you can always like revert to a prior process to restore state and health to your infrastructure here. And so these were the 3 bottlenecks here that we were hoping to tackle. And we realized that as we grew as a company, like at 20 engineers at the time, in a future vision where we'd be like 100 engineers, 500, 1,000, these problems would only magnify. And so this came to our discussion on what we should build next. So the things we started wondering were, okay, can we eliminate this process here? What would help us move faster in such a slow moving industry space here? Infrastructure has been known to be move stable, right? Move slow and stable, but can we do something to help accelerate that? And 2 was like, if we had our sister teams, right, who were not necessarily in infrastructure, could they somehow gain the context they need to empower them such that they could ship their own services, such that there was no hyper-specific context and anyone could start shipping services? And lastly, could we add more safety and validation to add into the theme of moving fast as long as you have the appropriate guardrails? And lastly, how flexible could we be on this? Could we build something specific for our use case, but could anyone expand this if they needed it to be? Could people build their own custom logic? And could this blossom into what started off as a single seed for one project into multiple projects for a specific need for a given team? And so this is where Pulumi came in. And so I'll explain this bit by bit here. So let's say that we essentially wanted the user experience to be such that a developer can just submit code, and then based on the code that they write, everything would just be handled alongside, behind the scenes, seamlessly and without context. They would just need to be able to specify like, hey, I have the service, I want these resources with this configuration, submit a singular PR and have that propagate into our entire deployments. I'll explain the solution going from left to right here. So user develops a service, they check in their code, and essentially we build a binary based off that. And so we store that binary in like Docker Hub or any other container-based service that you want here. And then we label everything under a version data store. This versions data store then gets injected into the custom framework that we wrote, which is all TypeScript code. And essentially using the TypeScript code, you can specify what your deployment is. And so taking in that version and what we've written in Pulumi, right? We then have a separate stack for each deployment, and we take that code, we determine what the dependencies are, we determine what the configurations are, and then we generate the appropriate Kubernetes manifests automatically. We spin up the cloud resources as well, and then we check those into like two different forks of logic here. So the cloud resources actually get created in the CI/CD process, which we use GitHub Actions for. Then we use Argo CD to check a repository where we generate the automated YAML creations. And so Argo CD will then pull everything, and it has all the context for which cluster things should belong in. And so once it receives that updated context, it then spins up that specific service and its configuration on the given cluster or deployment that we desire. And then that whatever the service spins up, it had whatever reference it has to whatever cloud resource it needs, it already has it spun up, given that Pulumi has now created that on the sideline here. But that's like the quick high-level overview here. So maybe let's start off with like the user flow. Like as a developer or anyone in the company, what does that generally look like? So if I create a PR, this is what will happen here. One of the key things that I mentioned earlier was guardrails and visibility of things. So the scariest thing about infrastructure is generally that people are afraid to break things. People like to verify things very thoroughly before they hit production, as one should. Outages happen and customers are just generally affected by this, and so we want to prevent that. And so when you submit a PR, we actually simulate what the output would be for a given deployment. And so it actually comments it directly in your PR. And as you can see on the screenshot here, for every deployment, you then get like a small output to say like, hey, you've submitted this code. This is the expected changes there. And you're able to see that in your PR, and you're able to like verify, is this the expected changes I have? If not, perhaps my code is actually doing something differently than what I expect it to be. Next up is accidental deletion. So let's say you're cleaning up resources or you're changing something. The last thing we want is for people to accidentally delete things. And so we also have a CI/CD process integrating using Pulumi that actually detects when resources are going to be deleted, given the code that's checked in. And if there is code that's deleting cloud resources, we do notify people in the PR. And as you can see, there's like an error here to mention in your PR to say, hey, you're actually deleting a specific secret here or a certain resource here. Please verify this is what you want. And we actually have a separate process to like approve those deletions. So this guardrail is there in place such that people can move fast. And if there's a deletion detection, then people get notified. And even if this somehow actually slips in, because of Pulumi and the great feature they've developed for resource protection, when it actually tries to apply the update, if you actually don't go through the manual process that we've implemented here in the PR through that link that is mentioned, the changes actually won't go through. You actually have to give some validation to say, hey, I approve of this actual change here. And so there's a minimal chance that you're able to like delete a resource just through like an accidental like PR merge here. Oh yeah, and then lastly, well, in addition to the point I made, right? If something were to go wrong, detection is most key for infrastructure. Visibility is your bread and butter for how you monitor and deploy your services every day. Um, Pulumi, because everything is written in code, has really allowed us to extend our observability and even power it through Statsig. So whenever we update a deployment through a stack, we actually generate metrics, and we can actually receive those metrics in Statsig. And so using our own dashboards and our own alerting, we can actually detect when a deployment has failed to actually apply, and we actually get notified for it, such that on-calls can now know when infrastructure deployments are broken, and they can react in live time when something has been checked in and how to mitigate that very quickly. If I was on call, you can see that the Pulumi stack for Prod South America East 1 has failed to update, given that we've made metrics for that. And so I can then look at this alert and I can see, okay, where is this happening? And I can debug what the issue is, and I can put up a quick fix just to fix this deployment here.
That's awesome.
Okay, so then further extending along the framework, and from the earlier point that I mentioned about taking one project and using that to like bloom into a larger one, Pulumi has really empowered developers through code, not only just through supporting cloud resources, but also through supporting custom dynamic providers. So let's say Pulumi does not have support for a very specific platform that you're using, or even in this perfect case, actually, Statsig, for example. What Pulumi has allowed us to do is to write custom logic in TypeScript code or any programming language that you would want. And it allows us to create custom logic such that we can actually integrate a platform into the Pulumi framework that we've written itself. And so what you guys actually see here are two dynamic providers we've written for Argo CD and dynamic configs that is powered through Statsig. Now, how this works is that Argo CD requires like an application to capture Kubernetes manifests such that it can spin up the resources you need. And so instead of having to do that manually, right, the developer can just go into a repository, type in they want this service. And because we've written an Argo provider, it actually fully spins up that Argo app for you. So you actually don't even need to interact with the Argo CD platform to create your app. It's actually all tied together into one piece. So as soon as you check in your PR, the CI/CD will then reach this provider, make whatever API calls you've written in your custom provider to do the proper validation and creation, and handles everything else from the end. And then if there's any changes, you can also control that logic. These are some of the cool things that we have built with Pulumi. On top of just automated our deployments and our cluster builds and really empowering users to create their own custom solutions, we've been able to actually supercharge our deployments by doing automated regional rollouts. And we've written an extension for a product that we have called Statsig Release Pipelines. And what this allows infrastructure engineers to do is that when it comes to a deployment in prod, because we have everything written in code, we can actually control which regions roll out first. And then we can set that on a time interval. And then if that validation is all correct and all our health statuses are healthy, then we actually proceed with the next region. And that essentially propagates into like a full promotion region by region, which limits the blast radius when shipping new services and features. The next one, as I mentioned here, as we scale to over 2 trillion events a day, we want to handle certain scales very specifically. And one thing that we've addressed is that certain companies have more scale than others. And so we ran into this challenge where if a company had such high QPS, that would actually affect other companies, given that it would be the same microservice handling all the traffic. And so Pulumi has really allowed us to programmatically create deployments. And so we can now create per company deployments. And so that has allowed us to traffic shard according to which company you are to a specific subset of our deployment, fully dedicated with fully dedicated resources for a company. And so that has allowed us to like isolate deployments such that we can give per company specific needs depending on what the microservice is. The next portion that we've really done is, given that automation and creation of resources is seamless and easy now, we've actually created a shadow deployment of our infrastructure. And what we do is that we create a production version of it and we create a staging version of it. So it's actually a pre-prod version of that. And what we do is that we send some test events and some test requests through these two pipelines, and those pipelines essentially write all that information to a data store or a database of some sort. And what we do is that we have a validation job that happens every day before push. And so we're able to contrast what is in pre-prod and what is actually happening in prod without actually having it in prod, since this is a shadow deployment. And if there's a big delta, we're able to then identify what those changes are and determine if we should block push or not. And lastly, because everything is written code, we actually wrote our integration for GCP to pull down the costs of virtual machines. And so what we actually do is that we have this job pulling on the side. And so these are all really, really great features that we build. And I'm really excited for like what goes on in the future, because when things are written in code, when there's custom integrations that can be written, we can do a whole lot of things here. Some of the areas I'm super excited about are the ability to do multi-cloud. Given that we've expanded this beyond a singular person managing this all, we can now like automate a lot of things. And so now comes the interesting discussion of, okay, we're on a singular cloud. How can we scale this out to support multiple clouds? The next one is like automated cost resource management. Outside of virtual machines, can we actually apply this to more broadly all resources? Like if you need a Redis instance, a Mongo instance, can we somehow pull costs from providers and figure out what the costs of all our cloud resources are and optimize in that way such that we can reallocate resources with low utilization, scale down certain resources, and have that all done for us such that we lead to increased performance at the benefit of cost savings. And then next to experimentation with infrastructure, right? I mentioned earlier, if we have visibility and metrics on how our deployments are, can we start running experiments with infrastructure and deployments through maybe a platform like Statsig? Can I maybe spin up a deployment with one instance of a machine and then one with another, conducting an experiment and determine from an infrastructure perspective which one generates better results, and be able to like spin it down after you're done an experiment and tidy everything up, and then determine what is the best way to spin up your infrastructure. And lastly, like we've done per company deployments, that's on a microservice level, but what happens if we take this even one step further? What happens if we have a per company cluster? And let's say that even happens on a per region basis. That leads to the potential of having high availability, high resilience, and high protection for specific companies on a very, very custom basis here. We're able to work with companies and figure out their exact needs, and we can specify what kind of things we want to deploy for them. So there's a lot of exciting things that we can build. Only time will tell. We've only been using Pulumi for a year, and so I'm excited to see as we fast forward through things, what are the kind of exciting things we built here. So yeah, that's all the small presentation that I have here.
You mentioned this specific company shards. Like, I'm just very curious about that. Like,
Yeah.
at what level does it, is it just like, oh, this specific endpoint that's hit is its own microservice and we scale that? Or is it like whole, is it, what do you split out that way and when?
Yeah, I can give you a prime example. So we have customers like Atlassian and OpenAI, and you can imagine like just with OpenAI, like people using ChatGPT, the amount of traffic they receive on a daily basis. And so if they're running an experiment and all their requests come to us, that was quite a struggle to do, because of their shared QPS. If there was a shared microservice, you would imagine that if 99% of the traffic was OpenAI, it means that that 1% of mixed customers would certainly experience some bottlenecks based on like a noisy neighbor problem here. So what we did, as you mentioned here, we actually spin up a completely different separate microservice. And then based on the request, we actually have some logic in our load balancing that is able to detect which company a request is coming from. And then we simply redirect it to the appropriate deployment, which contains microservices and the cloud resources to serve that request for that specific company, such that a dedicated microservice is only serving that company. And so we can really scale that horizontally and vertically if needed to handle that sort of traffic pressure there.
And do you think that will grow? Like, I think you mentioned a little bit, will you eventually be duplicating your whole infrastructure for a big enough client, I guess?
Yeah, absolutely. I think that's definitely the future here. So let's say like my other example, like Atlassian, Atlassian is based in Australia. And so in a world where we had this fully like automated and down to a dime, I see a world where we spin up a Australia specific deployment, like full on cluster with a full replica set of like all the microservices, such that all the requests just don't even need to travel overseas. They actually just have like a local region that they can just hit, and we can maximize like sorry, well, I guess reduce latency in that sense because they don't need to do that cross-ocean hop. They don't need to experience any noisy neighbor problems from other companies. They have something fully dedicated to them.
That's awesome. Yeah, because like when you have multiple customers, like the a customer level is such a natural like shard. Like it's
Mhm.
yeah. So what was the biggest challenge in doing all of this? Like in the actual adoption process, I guess.
Yeah. I think the most challenging portion is the reason why I say that is because like when you're in a startup, the nature of a startup is chaotic. Everything moves so fast and the landscape is always changing because we are always acquiring customers and the needs, the target for success is always moving. Scale, things grow. And so we needed to find a way to determine what were the actual success criteria. What was something that we could hit and what was something that was reasonable to do such that we can then convince teams to onboard onto this and showcase to them that there is good potential in taking the extra time to build this correctly instead of just shipping blazing fast to meet deadlines here. And so I think there was an interesting technical challenge, but also it was a cultural challenge as well. Being able to convince organizations, entire like sister teams to adopt this process when they already have their prefabricated way of doing things was definitely like an interesting conversation. You need to change people's perspective on things and you need to challenge status quos on how to approach engineering and being able to convince teams like, hey, I know this seems like high effort right now, but convincing them of the long-term vision and what the benefits will be in the long run is was the challenging portion here.
That's awesome. Like I mean, it's awesome that you made that effort. I think it's a common sticking point, and like I wonder if where other teams are other teams willing now to go into the like the infrastructure code and make their own changes. Like, are you at that?
Yeah. So I think it was a little scary because like if you are not on infrastructure and you have to deal with certain things, you don't have the full context on how everything works end to end. And so also like talking about the technical challenges, right? How could we abstract away some of the things that happen on behind the scenes for a service that maybe like a generic engineer just probably doesn't really care about? They just essentially their end goal is I just want to hit my endpoint. I just want my thing deployed. And so figuring out what to abstract and what to expose was definitely a tricky design decision. And that itself is constantly evolving, especially even as we tackle multi-cloud. So being able to provide maximum customizability was what we built into the framework. So things are abstracted in a way where you use like a default configuration if those are things you generally don't worry about. But if you need to specify something specific, like you need a high amount of CPU for a specific service, or you need a specific node configuration for your cloud, we do expose those endpoints. It just really was finding like that correct balance and being able to integrate it into the framework here. That was like the tricky portion.
Yeah. No, I get that because it's like somebody might just, I want to run this. So they're like, oh, maybe now I need more compute for it. And then
Mhm.
how do you get the details right where they're not just overwhelmed by like, oh, here's how a request travels through our cloud. You mentioned at the beginning infrastructure being slow but stable. Like, what do you think that you can now move faster? Do you think you should move fast with infrastructure? I don't know. What are your thoughts now that you've adopted this new framework?
Yeah, absolutely. I think in an ideal world, everyone should move fast. And I think that's definitely what we aim to do here at Statsig. Like we are essentially trying to empower people to feel to have the guardrails to fail fast and ship as many things as they want with while minimizing the consequences here. And that's essentially what experimentation is. And I think that definitely extends to infrastructure. Generally what happens from my experience working at other companies is that people want to make an infrastructure change. There's a big design review. People, before even implementing things, they go through all these small details and there's all these buts and bits and process. And then that project never sees the light of the day because they finally determine the risk is too great. This happens, outage, and there's no easy way to recover from that. And so the thing that we were trying to challenge is that, okay, in theory, if you did not have that, what would happen? If you could fail, and so I think it became a challenge culturally and technically. Reframing how people see infrastructure is the goal here. The problem is not necessarily with like infrastructure in general as like a field, it's mainly with the tools that you have that enable you to move fast here. And so that is the thing we were trying to build.
That's amazing. That was a very exciting answer because yeah, can you be okay with something failing? I loved also in your demonstration like your use of the Pulumi preview and the guardrails around like deleting a resource. I think it's very smart. So did has this happened where you've caused outages and quickly recovered?
Yeah. So the thing is like absolutely. The working in infrastructure, like especially, oh, actually, it's interesting you mentioned that. So going back to the greatest challenges, when we were building this, there were definitely challenges because everything is simple once you actually have the groundworks and everything visualized and put on paper. But when you're working with the unknowns, there's certain times where, for example, we didn't have those guardrails because we were still building things. And so as we experimented with things, there were definitely certain things that happened like, oh, we misconfigured something, there was a bug here. And so that was a little bit of an interesting process, like building iteratively, like building a safety system while without having a safety system was definitely a definitely a challenging point here. But that's like the great thing about like such something like feature flags or dynamic configs with monitoring and observability. The philosophy is that as long as you're able to know what is going wrong, then you can then fix things. It's quite a different landscape when you are building something, breaking things, and then you don't know that you've broken things. So Statsig itself as a platform has definitely helped us with that for sure.
Yeah, I bet it's an amazing tool. So my last remaining question. Okay, maybe two-part
Mhm.
question for you.
Yeah, absolutely.
So if you were to do it again, what would you do differently? And then the second question is like, sell me on Pulumi. Tell me why you used it and why I should use it.
Mm-hmm. Those are really, really interesting questions. If I had to do it again, okay, actually, it's an interesting hypothetical. If I actually had to do everything again, if I had joined the company even earlier, I would have used this framework from the get-go. I think what happened was that the thing we were fighting as well was like people locked in their ways, but there was also like a lot of technical debt. People had done things a certain way, and being able to migrate to a system, it's scary and it's very time consuming. And so I would have used this right away because I think it definitely could have evolved and helped us accelerate faster. In terms of actual framework portions, I think I would have. Hmm, I think I would have envisioned multi-cloud earlier. I think that definitely would have changed our design decisions on how we structured things. Multi-cloud actually came up as a result of growth here as the company, but ultimately, in hindsight, it's definitely a path that all companies eventually take as they grow. Everyone has specific cloud needs, clients have specific tenants they want to exist on. And so I think it's just mainly more customization that I think. Really, like, I think the challenge was that we locked down too hyper specifically to a singular cloud, which
Mm,
suits our needs right now. But I imagine like maybe like 2, 3 years from now, we would have ran into issues. So that's why we're tackling this right now. Finding that right balance of flexibility and hard requirements is the thing I would have concentrated more on. I think I would have opened up the requirement more to multi-cloud and been like, hey, I think it's worth the time to look in this direction, even though we don't have multi-cloud, instead of hyper focusing on this one segment here. But that being said, the work is actively being done, and so I think it's just a matter of time before we reach that milestone. In terms of why using Pulumi, yeah, I have a lot of great things to say about Pulumi. Pulumi, as I mentioned, has empowered our developers. And essentially what I mean from that, like let's say something like Terraform or another platform, is that it's truly made infrastructure accessible to engineers. You don't need to learn a specific subset language. There are SDKs written in the most popular programming languages, such as like TypeScript, Python, Java. And so it means that like any sister team that generally programs in a familiar language, they can just hop in and they can start writing logic, or they can read logic that's been written out in a framework. And that I think is the accessibility portion that really makes this usable across a team and across a company. And then two, like there's just a lot of variety of features. The previews, the deletion protections, I think the out-of-box features you get are fantastic. And there's also a lot of options and customizability as well. You can make a custom provider to really suit your needs if you need something hyper specific. And so it's almost like they've essentially given you the tools, and it's essentially what will you build with those tools? Yeah, and so that's what makes it so flexible and powerful. So I think any infrastructure team, depending on what your needs here, because they're just a set of tools and it's accessible as code, you can really shape it to whatever your needs are.
That's awesome. That's amazing. So, yeah, if you are wrestling with fragile scripts, or I mean, maybe even before you get to 2 trillion events, but if you have anxiety, you can follow Tyrone's playbook and build a platform like this. So thank you so much, Tyrone. And if you haven't already, you should check out Statsig. It's a great platform for product development. Yeah, and if you're watching this, what are the big infrastructure bottlenecks you're hitting? Leave a comment or reach out to either of us, and I'll try to, well, I don't know if I'll have a solution for you, but I'd love to hear your challenges. So thank you, Tyrone. This has been awesome.
Yeah, thank you so much, Adam. Happy to chat about things and happy to see where the future takes for Pulumi here.
It's awesome.